Imagine you have 3 apples. If you take away 2, how many do you have? Now don't let the simplicity of this question fool you. It's less about basic subtraction and more about logical thinking. You might be quick to answer 1 apple, but let's take a step back and consider the phrasing of the question. Here's where the concept of subtraction comes into play. Most of us would instantly think 3 minus 2 equals 1. However, the question isn't asking how many apples are left, but rather how many you have after taking 2. So you started with 3 apples, right? But then you took 2. Those 2 apples didn't disappear into thin air. They're now in your possession. So the correct answer to this question is 2 apples. You took 2 apples, so you have those 2. Simple, isn't it? If you multiply all the numbers on a phone's number pad, what is the result? Let's dive into this second conundrum together. The numbers on a phone's number pad are 0 through 9. So, if we were to multiply them all together, we would multiply 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, remember the fundamental principle of multiplication. When you multiply any number by 0, the result is always 0. This principle is a cornerstone of arithmetic, and it's all because of the unique properties of the number 0. So, as we multiply these numbers together, as soon as we include 0 in our calculations, the entire product becomes 0. It doesn't matter what the other numbers are or in what order we multiply them. Any number multiplied by 0 equals 0. That's the magic of 0. What 3 positive numbers give the same answer when multiplied and added together? Now, isn't that a puzzle to kick your brain into gear? Let's break it down together. Consider the multiplication aspect first. If 3 numbers multiply to the same result, one of the numbers must be 1, because any number multiplied by 1 remains the same. Now, let's move on to the addition. For 3 numbers to add up to the same result, the sum of the other 2 numbers must also be 1, as adding 1 to it would yield the original number. So, what numbers meet these criteria? Well, it's as simple as 1, 2, and 3. 1 times 2 times 3 equals 6, and 1 plus 2 plus 3 also equals 6. This puzzle is a great example of the mathematical concept of factorization. The numbers 1, 2, and 3 both add up and multiply to the same result. 6. Isn't that fascinating? If it takes 5 machines 5 minutes to make 5 widgets, how long would it take 100 machines to make 100 widgets? A clever question that might cause you to jump to the conclusion that more machines and more widgets equals more time, right? But hold on, let's step back and consider the concept of ratios. Here's the thing, one machine takes 5 minutes to make 1 widget. So if we increase the number of machines to 100, each machine still takes 5 minutes to create its own widget. The key to understanding this riddle is realizing that the production time is not dependent on the number of machines or widgets. The question is essentially asking how long it takes for a machine to make a widget, and that's 5 minutes. So whether we have 5 machines or 100, the time remains constant. It still takes 5 minutes. More machines don't mean more time. That's the power of ratios. What digit is the most frequent between the numbers 1 and 1000, inclusive? Now that's a fascinating question. Instead of trying to count each digit individually, let's approach this question using the principle of frequency distribution. Consider this. For every 100 numbers, each digit from 0 through 9 appears 10 times in their last place. Similarly, for every 100 numbers, each digit appears 10 times in the tens place. Now, extend this pattern up to 1000. However, there's a catch. The digit 1 has an extra set of 100 appearances. Wondering where? Well, it's in the hundreds place for numbers 100 through 199. So we have a clear winner here. Between the numbers 1 and 1000, the digit 1 appears most frequently. And that's how, by understanding frequency distribution, we can solve this mystery more efficiently. The number 1 appears most frequently. It's all about understanding frequency distribution. How many times can you subtract 10 from 100? Now, that's a riddle that might seem simple at first glance. You might be tempted to quickly divide 100 by 10 and say 10 times, right? But let's take a moment to appreciate the subtlety of the question. The riddle is not asking how many tens are there in 100. It's asking how many times you can subtract 10 from 100. And that's a different story altogether. Subtraction is a continuous process. When you subtract 10 from 100, you're left with 90. So the next time you subtract 10, you're not subtracting it from 100, you're subtracting it from 90. And so on. So the answer is quite different from what you might initially think. You can only subtract 10 from 100 once. Then you are subtracting from 90, not 100. So let's keep these subtleties in mind as we navigate through our mathematical journeys. In a year, some months have 30 days while some have 31. How many have 28 days? Now, this question might seem straightforward, but there's a catch. Our minds are often quick to categorize February as the only month with 28 days. But is that the only correct answer? Let's dive deeper into this conundrum. Each month in our calendar, be it January, August, or even December, has at least 28 days. The difference arises in the fact that some months continue beyond the 28th day, so the true answer isn't just one month, but all 12. This question highlights the importance of logical thinking and how our initial interpretations can lead us astray. It's a reminder to step back, reassess the information given, and not rush to the obvious conclusion. Every month has at least 28 days. Sometimes the answer lies in the way you interpret the question. What is the number of the parking spot covered by the car in this arrangement? Here we are, folks, at the 8th puzzle, and it looks like we're in a parking lot. Now, this one is a perfect example of why pattern recognition is such a valuable tool in problem solving. At first glance, the numbers may seem haphazardly arranged, but there's a method to the madness. Just flip your perspective. The key to cracking this riddle lies not in what's visible, but rather in what's hidden. If we look at the numbers upside down, we see a pattern. It's not 21, 22, 23, but rather 12, 13, 14. So what's under the car? It's a bit of a head turner, isn't it? But if you followed the pattern, the answer is clear. The pattern is in reverse. The covered spot is 87. Isn't it fascinating how a change in perspective can reveal the answer? A plane crashes on the border of the US and Canada. Where do they bury the survivors? Now, this ninth enigma might seem a bit morbid at first, but let's dissect it together. The key to solving this riddle lies not in your geographical knowledge, but in your comprehension skill. When we hear the word crash, our minds immediately jump to the worst-case scenario. But the question isn't asking about fatalities or crash locations. It's asking about survivors, individuals who have, by definition, lived through the event. So where do they bury the survivors? Well, they don't. Survivors, by the very nature of their title, are alive and kicking, and we don't bury the living, now do we? This question serves as a stark reminder to always read and understand the question in its entirety before jumping to conclusions. Survivors aren't buried. Always read the question carefully before answering. If a red house is made from red bricks and a blue house is made from blue bricks, what is a greenhouse made from? This question, seemingly simple, is in fact a test of logical reasoning. It's a classic trick question that tempts us to think within the confines of color and material matching. But is it always about color? The secret to solving this mystery lies in breaking free from the color-coded assumption and turning our attention to the functionality of the object in question. What is a greenhouse? It's a structure that nurtures and protects plants, allowing them to grow in a controlled environment. And what allows sunlight to penetrate while also providing shelter? That's right, glass. So the answer to our 10th mystery isn't green bricks, but glass. Yes, a greenhouse is made from glass. It's a reminder that it is not always about color, is it? A beautiful lesson in out-of-the-box thinking, wouldn't you agree? We've journeyed through some engaging mathematical puzzles today. We've ventured deep into the realms of subtraction, unearthing its nuances and intricacies, and we've multiplied our understanding of multiplication. We've cracked open the cryptic shell of factorization, and we've navigated the complex waters of ratios with finesse. We've also delved into the world of frequency distribution, a world where data dances to the tune of statistics. We've engaged in the art of continuous subtraction, a method that may seem simple but can be quite powerful. We've honed our logical thinking, sharpening it to a fine point. We've identified patterns, those hidden threads that weave the fabric of mathematics. We've read carefully, understanding that every word in a problem matters, and we've used logical reasoning to confront and conquer each challenge. Remember, mathematics isn't just about numbers, it's about understanding patterns and applying logic. Keep exploring and keep learning.